So probably people have been off and tried it now, but at the end of the last section I suggested that some people may have discovered not a problem, but certain facts about the way this stuff works, and we're going to discuss that now and look at solutions and actually how that extends things to be a lot more flexible and wider anyway.
Right. Yeah, so you mentioned if you took this code that we're working with right now, this function, this calculate factorial function, and if you accidentally or on purpose input this function or move this function beneath the main function, then you'd actually get an error. We can, put it in there and see what happens. But the gist of it is, what's actually happening here is when you go to actually call that function, the compiler is going to go through your source code and it's going to compile things pretty much sequentially. And so because the compiler won't necessarily or won't know about that calculate factorial function, if you put it beneath where you call it, it will generate an error because it doesn't think that the function exists. So I guess the question is, how do you deal with that problem and so forth? And the answer is you deal with that by basically by declaring your function interface. Now, so for example, if we wanted to do that here, I could actually go ahead and declare my function interface for that function up top here.
As long as you spell it correctly, of course.
Did I?
No, you're fine. Yeah, okay. You're okay.
And then what I'm doing is I'm telling the compiler, hey, I'm going to create this function called calculate factorial, and so you should expect that to be defined somewhere. I'm not telling it where. But these are the parameters that it takes, and this is the return value that it takes. And then it can generate its code and know that that function is going to be there. Now, if you don't actually define that function anywhere, then, of course, your code's not going to work. But assuming you do, then that will solve that problem for you. So in other words, you can create this declaration, as it's called. You can declare the interface of your function anywhere before it's actually used, as long as you define the function somewhere as well.
Okay.
Now, here, I guess that's kind of useful. It gives you the ability to move your function down beneath the main function and stuff like that. Mm-hmm. But at the end of the day, really, the place where this is actually useful is in being able to take these functions and break them out into modules. So you can have like your own factorial module, or you can have your own collection of functions that do whatever, whatever
so
kind
that
of...
I can use them wherever I want, whenever I want, in whatever I want.
Exactly, exactly. So again, it comes back to that sort of idea of isolating things and naming them. So you can have this group of functions that are all sort of related items, and you can collect them into a module and call it, my library of stuff, or whatever. Obviously you want to use something more useful than that as a name.
Quite good. It's my library of stuff.
Yeah. Although actually, I think I have one of those libraries in most of my code.
I think most of us have one of those libraries somewhere. My library, stuff library.
Yeah, exactly. So let's take a look at how you do that. So to create a library of just C functions, or if you wanted to create a unit, a module with C functions, then you'd go into your source code and you can come in here and you can right click or option click the source directory, and then you can choose new, and you can choose new file, and then you can choose to create a new C file and give it a name, like, for example, in this case we'll call it factorial, if I can spell that correctly, factorial, and that will actually create for you a factorial.h and a factorial.m file, or a .c file, which indicates that this is a C source file.
Okay.
Now the header file, so essentially these two files are created, this .h and this .c. The .h is what's called a header file. And the header file is used to put the interface declarations for all of the functions that you're going to put the implementations of for that library of code that you want to create.
So the line that we put at the top of our code just now, in order to declare that there was going to be a function called something, that's the sort of thing that would go in a .h file.
Exactly.
Okay.
The declaration of your function the functions that you're going to put into this module is what goes into the .h file. Then the actual definition of the functions themselves, right, also known as the implementation, you'll put that into the .c file.
Right, okay.
So let's do that. So for example, we take this this implementation here, or this declaration. We take that and we put it over here into the .h file.
Just like that, just drops in there, all done.
Well, sort of. So
Okay.
we're gonna do that, but we also have to add a special keyword onto the front of this declaration called Extern.
Right.
And what
okay.
that's going to do is it's actually going to say, I'm forward declaring this function. It's going to be contained in some external module, like this other source file. We didn't need it before because it was all right there in our current source file.
Okay.
But in this particular case, because it's going to be in another source file, we need to have this extern keyword.
So it's doing the same job of saying there is going to be a function called this, but also
Yes.
having to tell it it's somewhere else.
Yes, exactly.
Okay, yeah.
Then we come back over here and we grab our function. Now we don't have to have the extern keyword for the actual function definition. It's only for the declaration. So we're going to take that guy and we're going to put him right in there, just like that. So
Okay.
just by doing that, right, then we should have, basically, we've now created this unit called factorial. It's got an H file and a C file. The C file contains the implementation of the methods that are declared in the .h file.
Okay.
So now, when the compiler compiles this, it'll take that .c and .h file and it'll compile it into a .o, just like we saw when we first created our first program for the main source file. It'll create that .o and then it'll link the .o with our main file, and all of those functions will be available to it.
Just by magic.
Almost.
Okay, right. Sounded too good and too easy.
There's one more thing we actually have to do, and that is the header file. In order to get those declarations into our source file, we have to include the source or the factorial header file in our main source file. So in other words, if we go over here to the main file here, we need to also add an import line for the factorial.h header file.
Okay, just like there is with the foundation one, which we haven't got onto what's in foundation,
Right.
but we said we needed. So basically that is during the preprocessor, if I just remind myself, during the preprocess phase, that's going to copy in that file, the .h file,
Right.
which has got the declaration
The
in.
declaration, correct.
Okay.
Right there.
It's still marked external, so that will be
Right.
telling us it's there, but it's in another file.
Exactly. And then the factorial.c will get compiled, right,
Yeah.
into a .o, which will be linked with our application, and that'll make that implementation available when we actually use it.
Now all that bit happens with the .o because it's all in the same project and all gets munged together, is it?
Yes.
Okay. So we don't need to point it to that file in any way at all. That just happens because we're all there. And
Yes.
Okay.
Now, there's a couple of different things here. One of the things that you might notice right off the top is when you compare this import line to the foundation import line, the foundation import line is using these angle brackets, and the factorial one is using quotes. And this is important, obviously. You know, just about everything in programming languages means something, even, you know, little subtle things like this. Essentially, what this means is when you import a file using angle brackets, it searches the system's include paths for that. And because Foundation is included as part of the operating system, as part of the compiler environment, right? Those header files and those object files are actually located off in system header file directories, not part of your project.
Right, okay.
When you use quotes like this, it's actually telling the compiler to look in your project for this header file.
Makes sense.
So it'll actually find your factorial.h file faster by using the quotes because it'll look right there in your current directory.
Okay, so while we're on the subject, and if I'm jumping ahead, then just tell me to be quiet and go away and be quiet or whatever else. When we were in our factorial.c file, so our code file, that had something that looked very similar, but it used the word include, not import.
Yes. So, no, that's great. This is a great time to talk about that. Include and import are very similar. Essentially, include was used prior to Objective-C. That's actually part of the C programming language.
Okay.
And they really do basically the same thing. They include another file in your existing file. The difference between include and import is that import will automatically do certain checks to make sure that you're not accidentally including the same file twice and those kinds of things.
Right, so I'm guessing here, because we asked it to create a C-based file, it dropped back to using C standards rather than Objective-C because it wasn't sure where we were going to use this stuff.
That's exactly right. And that brings up another...
So we could just use import here and it'd be fine?
Yes.
Because we're writing an Objective-C program?
Yes, absolutely.
Okay.
Now, if you were creating strictly a C program, that wouldn't work. You would have to use include. But since we're dealing with Objective-C here and, you know, we don't really want to use dirty C anyway. We want to use Objective-C, right?
Okay, yes.
We don't really, you know, generally speaking, in 99% of the examples that we see here, once we get into object-oriented programming, you're going to see nothing but imports. And generally speaking, people don't even need to worry about using include anywhere.
Yeah, I mean, so we're doing C stuff here because we're trying to show the concepts, and the concepts are still at the C level.
Yes.
Because we haven't quite got to the Objective-C stuff yet, so... I guess you chose a C file to keep it simple and stop a load of other clutter coming in that we haven't talked about yet.
Yes.
Okay.
Now, that brings up another interesting point, though, and that is that we've created this file. It's a .c file. Now, when the language is, or when the compiler is compiling your source code, it'll use the extensions of your files to determine what kind of source code it is that it's compiling. And because we've got a .c extension on this particular file, it's going to compile this as straight C, which is just fine because everything that we're doing in this particular function is just plain old C.
Right, it's okay.
So there's nothing special here. But if we did go and change this to be import instead of include in this particular file, it probably wouldn't work because that's an Objective-C thing. And this is going to be compiled as a C source file. But for our purposes, that doesn't really matter. I mean, we're just, you know, this is sort of to give you an idea about functions and things like that. And the vast majority of the coding that we're going to be doing is going to be Objective-C. Using import is going to be fine. And now, if you wanted to use an Objective-C construct in this particular source file, then you would want it to be compiled as an Objective-C source file. So to do that, what we would actually do is we would actually change the name of this file to factorial.m.
Okay, so it's from that M extension it knows it's Objective-C.
Exactly. So, and there's all kinds of these extensions in Xcode. So there's .c will compile it for a C file. .cc will compile it as a C++ source file. .m compiles it as an Objective-C source file. .mm compiles it as an Objective-C++ file, which is...
Scary.
Not something we're going to discuss.
Okay, good.
But it's there.
C++ scares me. Objective-C++ just sounds too scary.
It's all good. And, you know, there's other things like that. There's, you know, you can do assembly files and things like that. But again, for our purposes, we're interested in .m.
But I'm making the assumption that, you know, because Objective-C is a superset of C, that the fact we've named this .m is going to compile it as an Objective-C, but because this is C, it's just going to compile.
Precisely. Exactly. And so it all just works, which is what we like.
Great.
Now, there's one other thing to look at with these, and that is if you have multiple targets as part of your project, you know, you can create additional targets down here. And so for example, in some of my applications that I use, I might have a full-on version, and then I've got a light version, right? And those light versions maybe don't have all of the functionality of the full version, and so I want to include certain source files in the full version and not include certain source files in the light version.
Right. Okay.
So I don't necessarily want to always link with all of the code in my project. So controlling whether or not a particular module is linked with your executable. In other words, remember we talked about this guy here, this factorial.h or this factorial.m is going to be linked with your source file, with your executable, which is going to make those functions defined in there available to your function or to your executable, right?
Right. Okay.
So if I wanted to not include those because I'm only using them in some other target in my project, then I can select that file there, and I can go to the detailed view of the project detail panel over here, and I can uncheck that target box.
Right.
And that determines whether or not that particular unit will be linked with my executable.
Right.
So now if I were to compile this and try to run it, because I'm actually using those functions, if you don't link the implementations with your executable, then the functions won't be available and it'll give you an error. It'll say undefined symbol when you go to compile it, okay? So in other words, if I tried to do that here, because I'm actually using that code, because I'm using that function here, it would give me an undefined symbol. So, so that's something to be aware of if you are, again, this is something it's sort of an advanced topic, but the point is that this is how you control what units are linked with your application and which ones are not.
Right.
The same thing goes for the system software, the system functions that we were looking at earlier. We talked about the foundation here, right? And the foundation is actually a framework that's provided by the compiler, by the operating system. And so we're including this here, we're importing it here, and that's what's giving us this nslog function here, right?
Right, that's in the foundation, okay.
Just like we've created our factorial unit, which has our calculate factorial function, Apple created the foundation framework, which includes a unit that contains an nslog function.
Now, effectively, I mean, we don't really need to go here, but just to understand, a framework is just a construct under which loads of these sort of units are gathered together and accessible to developers.
Right, exactly. And so the place that those are actually in your project is under the external frameworks group. So if you look there, this is the foundation framework. And by including this in our project, we have access to all of those functions and classes and everything else that Foundation provides to us.
So when we first chose to create a new Foundation application, part of that choice then set our project up to include this framework for us.
Yes.
If we'd started, I guess, with a project that wasn't a Foundation project, but was just a raw C console project, and then we'd later changed our mind, we could have come along and added this.
Yes.
Included this in a later time, just like we have now with our own functions.
Yes.
And made it work. So it's not a one-time choice. It's you can do it when you want to.
Yes. And you can add additional frameworks. There's lots of these frameworks available. We will talk primarily about Foundation because Foundation is Objective-C without the Foundation framework is like, I don't know, peanut butter without jelly. It's not.
Some people may think that's a good thing.
I suppose you're right. It's not really complete. The Foundation framework gives you a lot of tools that are necessary to write code with Objective-C. So we're going to talk about Foundation as part of this program, but there's also all kinds of other frameworks available. For example, if you do iPhone development, there's the core location framework, which gives you location data and stuff like that. On both OS X and iPhone, there's the core data framework, which gives you data persistence. And so you can add those to your project at any time just by going in here to your frameworks and choosing add and then external frameworks. And then that'll bring up a list of all of the frameworks that you can choose from. So as you can see them here, and you can go through and choose, like if I want Audio Toolbox or whatever, and I can add that framework to my application. And essentially what that does is it makes the directory that contains the interface files for that framework available to be searched by using an import statement using those angle brackets. And it also causes the implementation files for that framework to be linked with your project so that the implementation of those functions and classes and stuff like that is available at link time.
So basically, it's about building up the resources, spreading things out, using it again if we need to, getting hold of the system stuff without having to rewrite it and put it in there. So there's a lot of important concepts in there.
Yes.
Which I'm sure are familiar to people from other languages and that as well, maybe not the way of doing it. But if this is the first language you're learning, then you really need to get to grips with that.
Yes.
We don't put everything in one big file.
Exactly.
Okay.
It's hard to think about lots of things at once. Give them names, compartmentalize them.
So, are we done on this section? Do you feel you've covered what we need, or do we need to know some more?
We are done.
That's good. That's good. So, what are we going to do when we get back?
When we come back, we're going to talk about controlling program flow, which we've seen a little bit of that so far. We've seen ifs, we've seen whiles. Actually, we haven't seen whiles, but we've seen a little bit. We've seen some if statements and things like that. So we're going to talk about things that let you control how your application moves through the instructions that you've given it.
Great. Then we'll do that when we get back.